Hello guys, today before jumping to our topic, I just want to discuss something which seems funny but is true and very popular. Yes, I'm talking about the name of the child of Elon Musk. He recently tweeted that he named his child this. Doesn't it seem like the name of a robot? Now, what is the most difficult thing for people? How to pronounce it? Its pronunciation is not that much complicated. Musk himself revealed that X is just a letter. This symbol is pronounced as ash, and A12 is his contribution, which stands for Archangel 12 and aircraft. So the final pronunciation becomes X ash A12. It doesn't seem complicated. Now let's move to our topic. Maybe most of us know that astronomers have made a rare detection of an Earth-like planet 25,000 light years away from us in our own galaxy, Milky Way. Even there will be a multitude of Earth-like planets sprinkled over our galaxy, but to find them is not an easy task. Today, only a third of the over 4,000 exoplanets found and confirmed are rocky, and most of them are within few thousand light years away from us. Therefore, every new discovery of an exoplanet is exciting, but this particular discovery is even more exciting yet. This planet belongs to a much smaller subset of exoplanets orbiting at an Earth-like distance from its star, and it is whopping 24,722.65 light years away from us. It is very far away from us, but it is close to or even be in the galactic bulge. Now, most of you would be familiar with this term galactic bulge, but those who don't know about this, galactic bulge is a region densely populated by stars in the center of a galaxy. There is one more thing present there. Just think about it. I have told you in one of my previous videos regarding galaxies, a supermassive black hole. If you haven't seen that video, then go check it out, it's really interesting. Most of the exoplanets have been discovered by using one of the two methods. There's the transit method, which detects an exoplanet in the regular minuscule dips in a starlight when an exoplanet passes in front of it. And there's the wobble method, which detects minuscule wobbling exerted on a star by the gravitational influence of an exoplanet. But there is a third method also, based on the predictions of general relativity, gravitational microlensing. Now, microlensing is really a vast and complicated concept to explain in this video, so I will give you just some basic idea regarding it. To understand microlensing, you should know one basic thing, that light bends due to gravitational influence. Now I will try to explain you this phenomena in the simplest language. Consider a star behind a planet and an observer far away from it. Now a light ray approaching a planet from the star will bend due to planet's gravitational influence. This will generate multiple distorted, magnified and brightened images of the background source for the observer, just like this. So, by this distorted images, astronomers can figure out exoplanets. Now, why this thing happens and how it works is really vast and complicated concept which I am not gonna explain in this video, but I will come up a video regarding this in future. Now, I have gone into details of microlensing because this planet has been discovered using this technique, and it is one of the lowest mass planets ever discovered using microlensing. This planet is a super Earth clocking at around 3.96 times the mass of the Earth. A super Earth is an extrasolar planet with a mass higher than Earth but lower than those solar systems icy giants Uranus and Neptune. The star it orbits is really small, just 0.12 times the mass of the Sun. So the researchers couldn't determine whether it was a low mass star or a brown dwarf, and the orbital distance between the star and the planet is between 0.63 to 0.72 astronomical units, around the distance between the Venus and the Sun. But because the star is so small, the planet moves around it pretty slowly. So its 1 year is equal to 617 days. But we won't know if the planet is habitable or not. For one, we don't know the nature of the star. The temperature and activity level of a host star play a big role in the habitability. And the second thing, that the star is too far away that we can't know that it has an atmosphere or not. So overall we can say this research does demonstrate the extraordinary power of the gravitational microlensing as a tool to find those distant low mass stars. If you find this video interesting, then please like my video and drop your valuable comments in the comment box. And please subscribe to my YouTube channel Knowledge Row, as I will be back with more interesting and knowledgeable videos. So for today, that's all. Thanks for watching.